Hello and welcome to another fun-filled adventure with Mr. Sims in Algebra 1. Today what we're going to do is this Cycle 4 test incentive where you can earn 10 points. So once again, make sure you're following along with me as we do it and that you actually have kept track of just everything that I said, because it's important that if you don't have these components, especially the special components that I say, you're not getting credit for the video. So once again, first thing I want you to do, in the upper right hand corner, I want you to put your first and your last name, your first and last name. Underneath that, I want you to put your period number. Go ahead and put your teacher's name. And then under all that, I want you to put I can do this, all right? With a big exclamation point after it. I can do this. All right, so that's what I'm looking for. I can do this. All right, so let's start off with that. All right, let's go ahead and get started. So once again, I'm going to basically take about 30 minutes of your life to help you study, all right? So what we're going to do is we're going to just jump right in. Make sure you have that paper handy and the pencil, and anytime I say to do something, make sure you're doing it so that you can get the credit for it, all right? So the first thing we're going to do, we're going to start off with some questions that I chose out of all these here. So let me go ahead and make one more layer real quick. This is going to be my drawing layer. I got to move it all the way to the top here. All right, so this is called drawing, and I'm going to start the timer for Alexa. So Alexa, start a timer for 30 minutes. Let me try that again. Alexa, start a timer for 30 minutes.
30 minutes, starting now.
All right, so now what I'm going to do is I'm basically going to take 30 minutes. I'm going to get through as many problems as I can in that 30-minute span. All right, so without further ado, let's go ahead and jump right in so we can get to some great, amazing, fun problems. So the first thing I want to do, I'm going to go ahead and jump in to question number 34. On the study sheet, which says, which equation has infinitely many solutions? So if I'm asking the question, which equation has infinitely many solutions, what I want, remember that what gives me infinitely many solutions is when you have identity. So I'm looking for identity, right? And if you remember, identity is when you have something on the left that is the same exactly as the thing on the right. So in this case here, I have 5x plus 4 is equal to 5x. Well, if I subtract 5x from both of these here, right, I'm going to get, these are going to drop out, but I'm going to get 4 is equal to 0. This is not identity. In fact, this one here is no solution. So it's not identity. This would be no solution, all right? I know that it looks like chicken scratch, so just bear with me, all right? No solution. This one here, 14x plus 6 is equal to 0. I'm actually going to get an answer here. If I subtract 6 from both sides, right? If I subtract 6 from both sides, I'm going to get 14x is equal to negative 6. Well, I can, negative 6. And I can already see here that I'm not going to get a situation where something on this side is the same exact thing as on this side. In fact, my x's aren't even going to drop out. So this is also not identity. Remember, for identity to happen, basically your x's have to drop out and you have to have a constant on one side equals a constant on the other side, right? So you could have something like 4x equals 4x. That would be identity, right? Or 3x plus 4 is equal to 3x plus 4. This would also be identity, right? Or you could even just get 4 equals 4. I don't know why I'm using so many 4s. Let's do 9. 9 equals 9. All of these would be examples of identity, right? In which case, it doesn't matter what x is. Whatever x is, it's going to be the same on both sides, so it's going to be a solution, right? So none of these have worked so far. Let's look at this one. 6x plus 7 is equal to 7 times x plus 1. So let's look at this real quick. So these combine, 6x plus x is going to combine to 7x, right? So now I have 7x plus 7 on this side. Well, I'm going to go over to this side now, and notice I have a distribution of 7. So I'm going to distribute that 7. I get 7x, right? 7 times x is 7x, plus 7. And that, to me, actually looks like they're exactly the same on either side. In fact, if I were to subtract 7x from both sides, the x's would completely drop out, and I get 7 equals 7. So that actually, to me, looks like identity. But I always like to be really sure, so I check all my answer choices, and that's just a good habit to get into. So let's look at this one here. If I have 5 times x plus 2. I'm just going to rewrite it to give myself some room, right? In fact, let me just go ahead and distribute here. I'm going to distribute that 5x plus 2. So I get 5x plus 10, right? Because 5 times x is 5x. 5 times 2 is 10, right? So 5x plus 10 is equal to 5 times 3x is going to be 15x, right? 5 times 2 is plus 10. Well, I can already see that this is not the same thing, right? These don't look the same. In fact, if I subtract the smaller x, I'm still going to have an x over here. This is not identity. If you want me to prove it to you, I'll just do it real quick. Negative 5x on both sides, right? You subtract 5x on both sides, and you get 10. These cancel out. You get 10 is equal to 10x plus 10, right? I subtract 10 from both sides now, and I should get 0 is equal to 10x, right? I divide by 10, right? Divide by 10, 0 divided by 10 is still 0, right? So I get x equals what? 0. And that is a solution. If you look at that and you think that's no solution, that's not correct. This right here is a solution. This is the solution, x equals 0. So in this case here, that is not a answer that we're looking for, because we're looking for identity. Once again, the only one that matched that is H. H is my winner, winner, chicken dinner. Moving on to 36. What is the slope of the line graphed below? Be prepared to bubble your answer on the grid. At this point, what I'd like for you to do is in the very center of the page, I'd like for you to draw a circle in the very center of the page. And in that circle, I want you to put math rules. All right? Math rules in the very center of the page. All right? So once again, in the very center of the page with the circle, inside that circle, write math rules. You can even give it an exclamation point if you want. All right, here we go. Moving on. So what do we got? We're on 36. What is the slope of the line graphed below? Be prepared to bubble your answer on the grid. So this one here, they want me to get the slope of the line. Now, I'm going to be honest with you. Some of our times when we made it on the study sheet, when we were converting it out, it really struggled with getting the arrow in the right places. So some of these are going to look a little bit jacked up. So here's what I'm going to do. I don't normally suggest this, but in this instance, just this instance here, I'm going to tell you to use this point and this point. And I am very aware that those are not actually on the grid. We're just going to pretend, for the sake of this, that it falls perfectly on this point and perfectly on this point. So once again, I'm pretending. Are we going to do that during the test? No, on the test, it's printed out correctly. On the study sheet, for some reason, it got jacked up, okay? So once again, you don't normally do this. Normally, you're going to look for that one that literally fits, like, not even that good, literally fits perfectly on the line. It'd look more like that, where it's going perfectly over that point, all right? But in this case here, I'm going to use these. We're going to pretend, right? And so what I got here, I'm going to find the slope of this. Remember, your slope is rise over run. In other words, your m, which stands for slope, is equal to rise over run. So I need to get my rise over run. I always start with the left-hand point first. This is the leftmost point. This is the rightmost point. So I start with my leftmost point, and I'm going to do 1, 2, 3, 4, 5, 6, and 7. So these are the 7 is my rise. My rise is plus 7, right? And then I'm going to go to the right, 1, 2, 3, and 4. So that would be 7 over 4. And once again, you just leave it like that. My slope is 7 over 4. And you always want to leave it in the fraction form, because with the decimals, it's harder for us to see exactly what the slope is in an equation. So we prefer to leave it as a fraction. So always leave it as a fraction unless you're specified to do otherwise, okay? So in this case here, actually, you'd have to bubble your answer. So this one, you'd have to actually calculate it out and then bubble your answer in the grid. And so I don't know what 7 divided by 4 is. Alexa, what's 7 divided by 4?
7 divided by 4 is 1.75.
All right, so if I was putting it in the griddable like they want, I would have to put in 1.75, all right, just to make that clear, because you can't put a fraction in the griddable. All right, moving on to the next one. Ding! All right, so this problem here says, which best represents the domain of the function. So remember, if we're looking for domain of the function, we want to know all the possible, domain means x values, right? So I'm looking for all the possible x values that could be here. Well, I'm going to look at this first of all and just say, is this discrete or is it continuous? Well, notice I have separate points. If you have separate points, that automatically tells you that this is not continuous. So because it's separate points, this is in fact discrete. So remember, discrete values, if you have discrete values that are all like separate points, you don't have a line, so it can't be any point in between, so you can't have an inequality. Instead, you're going to have something where you have like a value, comma, value, comma, value, comma, value, something like this, right? If it is continuous, right? If we have a line, why am I having so much trouble down? There we go. If we have a line, right? Like let's say it were a line like this, then I could have values all from here to here. So I would need an inequality. I need something that looks like this for domain, right? Where I have x is less than 4, negative 4 to 2 or something like that. Does that make sense? So in this case here, because they want to know the domain of this function and its discrete values, I know that these two are already out. In fact, y is completely out because y would be range and they want the domain, which is our x value, so y is already out because of that. X value, although x is interesting, and although it would go maybe from, I don't know, from whatever to whatever, it's out as well because it's, once again, a inequality, and that would have to be a line. So now I'm left with negative 4, negative 2, negative 1, and 1, or I'm left with negative 5, negative 2, and 4. Well, the problem that we have with this here is, once again, this is something that it didn't work out right when we made it, I guess, when it went over to the study sheet. But just looking at the points, I can actually figure out which one this is. I have 2 points that are on exactly the same x value, right? If they're on exactly the same x value, they're going to share that x value, right? So that's going to actually probably be either if they share the x value, I only have to list it once is what I'm saying. So this one here has 1, 2, 3 x values, and this one here has 4 x values. But you'll notice that these two share one. So because of that, I automatically know it's that one, right? Now, if I really wanted to say what is the domain of this based on the dots that I see, if I were to ignore all the answer choices, right? Like I said, it didn't work out. When we made it in the study sheet, it didn't work out, right? So if I were to actually figure out like what these are, this looks to me like 1, 2, negative 2.5 would be, so negative 2.5 would be one x value. Then we have negative 1, right? And then finally you have here 2, right? So negative 2.5, negative 1, 2. If you really want to find out the domain, that would be the accurate domain for this based on this picture here, right? But if the picture was right like it was supposed to be, the answer would have been B, okay? And that makes sense? All right. I hope that made a little sense to you. I hope it didn't confuse you. So once again, if you're just looking at this picture here, and I said, what's the domain? The answer is this right here. But given the answer choices, and I'm telling you the picture's messed up, then this was the right answer choice for that, if you reasoned it out like a puzzle. Anyway, moving on. Here we go. Number 32. Find the product. So when we say find the product, and you have these two things here, what I'm going to do is I'm going to multiply using FOIL. So once again, FOIL stands for first, right? First, outside, right? Inside, right? And finally, last, all right? So first, outside, inside, last. I could have done that better, I think. There's probably a better way to do that, but you get the idea. So here's first. My two first terms are this one and this one. These are my first terms, right? And so I'm going to go ahead and draw, do that so that I don't forget that I'm multiplying the first terms. I like to write an F2 so I remember it's my first, right? So x times x is x squared, right? My outsides are going to be x times 2, which is going to be plus 2x, right? My insides, right? This is my outside once again. My inside is going to be 5 times x, which is going to be plus 5x. Now I want to stress to you that what I've done is I've put this over this because they are like terms. I can combine these later. That's why I've stacked them like this, okay? Then finally I get the 5 times the 2, and that's going to be plus 10, and I just write it there. Now at this point I need to add both of these here. And so I get x squared. I'm going to combine these like terms to make plus 7x, right? Finally, plus 10, okay? Seg x squared plus 7x plus 10, all right? Hopefully that made sense to you. So once again, that's using FOIL, first, outside, inside, and last. All right, let's go ahead and move on to the next one. Let me see where we're at. We're over here. So given the function f of x is equal to x squared plus 6, what is the value of f of negative 3? So in this case here, what I'm going to do is what I tell you to do is whenever you see a one like this and you're trying to substitute in this f of negative 3, remember normally it's written f of x, right? So if it's written f of x, what we see here is they substituted negative 3 where the x was at, right? Now what I'm going to tell you, the way I tell my students to do is this. I tell them wherever you see an x, I want you to just put parentheses to start. And I tell them to do this step because I want them to get in that habit of making sure they put the parentheses. When you're really good at it, you can realize, okay, I need to put whatever my x value is in parentheses. If you don't put it in parentheses, you end up with some wrong answers, and I'll show you what that looks like. But here, I'm going to put it now f of negative 3. I'm going to put this negative 3 wherever x was. So in these parentheses, I put in negative 3. Now, if I calculate this all on my calculator, once again, f of negative 3, you don't do anything to it. You just basically just keep bringing it down, is equal to, now this negative 3 squared, I have to be careful of. Negative 3 squared, when it's in parentheses like that, what I'm saying is I want a negative 3 times a negative 3. Well, negative 3 times negative 3 is actually a positive 9, okay? So that's a positive 9 there. So what I need to do, I'm going to go ahead and erase that so it's not too confusing for everyone. All right, so what I need to do now is write positive 9, because negative 3 squared is positive 9, plus 6. Now, what I want to stress to you is if you forgot the parentheses here, what you would have got is this. You would have got negative 9 because it would have squared the 3 and missed the negative if you forgot the parentheses. So you would have got negative 9 plus 6, which would have ended up giving you negative 3. But that's actually not the right answer. That's if you forget the parentheses. Don't forget the parentheses. Because as it is, the right answer is 9 plus 6, which is 15. Okay, so once again, that's a big difference between 15 and negative 3. This one is no bueno. All right, the way you got this negative 3 here, once again, is because you did not put in these parentheses. If you did that, you got negative 9. And you can try that in your calculator. Type in the negative 3 squared, just like this. If you just type in negative 3 squared, it squares the 3 and then multiplies it by the negative. And so that's what happens, and it's very bad, very bad. So make sure, always put your stuff in parentheses when you substitute. Okay, moving on. Ding! The algebra class is taking a field trip. The cost of the trip will be $15 per student. No more than 60 students are eligible to attend the field trip. The function y equals 15x gives y the total cost of the field trip if x students go on the trip. Which best represents the range of this function? And I know you're thinking, I do not like this problem already. And I feel you, all right? I feel your pain. All right, so here we go. So the algebra class is taking this field trip, right? The cost of the trip is going to be $15 per student. They know no more than 60 students are eligible. So remember, the cost is going to depend on the students. So if I asked you which one's the domain, which one's the one that you can just change willy-nilly and everything else has to kind of follow it, then that's the one that's independent, right? So the one that you could change willy-nilly is the one that's independent. That's your domain. So in this case, the domain is the students, right? And it says that there can be no more than 60 students. So in other words, my domain in this case, right? My domain, you might be thinking it's x anywhere from 0 to 60, right? And if you thought that this was the domain anywhere from 0 to 60, hey, congratulations, you have like parts of people. Like, and you cannot have that with people. Remember, students are discrete. We do not want parts of students. So it is not this. This once again is the domain anyway. So this one's already way out. We know that this, first of all, it's a domain and they want the range. Range is going to be your y values, right? So this is not even answering the question right. But on top of that, it's failing to realize that students are discrete, not continuous. So in fact, this one is also out because this is continuous, right? And we are not looking for continuous data here. We're looking for discrete data. So I'm going to go ahead and cross that out because that is no bueno, like I said. Now I have this one and I have this one. Now if I'm looking at this one here, 0, 1, 2, 3, 4, all the way to 60, doesn't that look a lot like my actual domain? That's the number of students that can be in this trip, right? Because it says there's no more than 60. So 0, 1, 2, 3, all the way to 60. Obviously, there's no negative students. You don't have like antimatter students, right? So you have 0, 1, 2, 3 to 60. So this right here is my domain, but they once again do not want my domain. What do they want? They want my range. And so this actually, here's my range, but I'm going to show you how they got it. What they did was they started with the domain. They realized it's 0, 1, 2, 3, all the way to 60, right? And what they're going to do with that is they're going to multiply each of these by 15 because it's $15 per student, right? Because that's what it tells us, $15 per student. Or otherwise, another way they've said it is y is equal to 15x is the function, right? So that means if I plug all of these in for x, I should get the y value. So in other words, 0, if I plug in 0 for x, then I have 0 for y because 15 times 0 is 0, right? That makes sense? Once again, I'll show you over here. Y is equal to 15 times 0, which is equal to 0. So my first value is 0. My next value, y is equal to 15. I'm going to plug in my next x value, which is 1. 15 times 1, which is 15. So my next value is going to be 15. You can already see where this is going. Basically, it's already starting to go up by 15, but I'll do one more just to hit home. Y is equal to 15 times 2, which is 30, right? And you can now see the pattern is basically add 15 each time, right? And I'm just going to continue that pattern because I've now established a pattern. And I got to go all the way to my last one. So I got to go y of 60 to know what my, y of 15 times 60 just to know what my last one is. And if you do 15 times 60, you should get 900. So my last one I'm going to put is 900, and I'm going to write my beautiful brace. That's a beautiful one. What did I do over there? I don't know what that is. Let me try that. Erase. Let's try that again. Haha, beautiful. All right, so at this point, what you should have in the upper right-hand corner is you should have your first name, last name, period, teachers, and you should have I can do, what's that say? I can do this, right? With an exclamation point. In the center of your paper, you should have drawn a circle that said math rules. In the bottom left-hand corner, I want you to draw a fox. What does the fox say? All right, yeah, that was bad. Okay, moving on. So I want you to draw a fox, right? Once again, a fox. All right, here we go. So next one. We're going to go ahead and move on to the next problem. The next problem says the time it takes for an object to travel t can be found using the formula t is equal to d over s, where d is the distance traveled and s is the speed. Which of the following equations could be used to find the distance an object traveled? All right, so let's think about this for a sec. So it gives us the formula here. All right, so it says t is equal to d over s. Now they say which of the following equations could be used to find the distance an object traveled. So essentially they're saying this is the time it takes for the object to travel, right? This is the distance traveled and this is the speed. And they're saying which of the following equations could be used to find the distance an object traveled. In other words, what they're saying is solve for d. We want to take the same equation and we want to make it so that we can find d very easily from it. So we want to get d alone. So to get d alone here, I got to recognize what's currently happening to the d. Well, the d is being divided by the s. Well, the opposite of division is multiplication. So instead of dividing by s, this is an s, not a 5. Instead of dividing by s, I'm going to multiply now by s. And by multiplying by s on both sides, these cancel out. And I'm left with t times s, right, is equal to d. Or if I flip that around, that would be d is equal to ts, right? So anyway, this is my answer here. D is equal to ts. Once again, this was just solving a literal equation. If you freaked out just because it was all letters, don't freak out, though. It wasn't actually a very difficult problem, right? It was the same skills you've used all the other times. Just remember, you do the opposite of what you need to get rid of. So in this case, I needed to get rid of this s on this side, so I multiplied to get rid of it, right? And it went to the other side there. So if I look at the answer choices that match, it looks like the correct answer choice is A. D is equal to TS. Man, they didn't even make it too hard for you guys. Anyway, sounds good. All right, let's go ahead and move on to the next problem. That was fun with literal equations, right? All right, let's go ahead and do this one here. Which inequality best represents the domain of the function shown in the graph below? Now, I gotta be honest, this one's once again a problem that got messed up. So here's what I'm gonna do actually. I think I'm gonna try something. I'm gonna try and just get rid of this part here. All right, and I'm just gonna draw an inequality that that could fit this. Okay, so let's go ahead and let's say for a second that my line was this. Let's say my line was, let's see, I like this one. Here, let's do this. So -2, all right? I'm actually going to need to go off the graph just a hair for this, right? So let's say it was -2 here. I have an open circle, right? And all the way over here at 4, let's say this was 4 here, okay? I had another open circle. Once again, I'm sorry that there was something that messed up with the study sheet, okay? So just bear with me. But let's say this was the function I had, right? Or let's say it was even a straight line, okay? In this case here, if I wanted to find the domain, I'm looking at the x values, right? So my x values, it looks like it goes from -2, right? It's a continuous line, first of all, right? So I'm going to draw my inequality where I have x is less than and less than. I would tell my students always start with that, right? And then I'm going to put my lower bound here. What is the lowest number it can be? Well, it looks to me like it can be -2. There's 1, 2. So it can be -2, right? And then what's the highest number it can be? Well, it looks like it can be 4, right? Now my question then has to be, does it include this point or not? Well, both of these are open circles, and as you remembered, open circles correspond to either less than or greater than, right? If you have a closed circle, it corresponds to less than or equal to or greater than or equal to. So what I'm saying is this: if you have an open circle, it can't not actually be that point. So because it is an open circle here, I cannot put the equal sign here or here. Now let's just try to do something a little bit different. Let's say both of these. So in this case, if I left it just like this, the answer would be B. All right? Now let's do it again, but now if I color in just this circle here, well then none of the answers would be right, right? Because this one would have to be -2 is less than or equal to x, and this one's the closest one, but this one still be open, right? So it doesn't actually work with this one, because this one tells me that it should be closed on that side, right? But let's say I did close it here, and I made it 2 closed circles. Now what's the right answer? Now the right answer is this one, okay? So once again, you look at your endpoints, you look at if they're open or closed, right? If they're open, if it's just a regular circle, you're going to use a less than to represent it, right? In this case, a less than. If it's a closed circle, you're going to use a less than or equal to, okay? So in this case, when I'm done here, it's -2 is less than or equal to x is less than or equal to 4. All right? Hope that made sense to you. If you're still struggling with that, come to tutorials and I'll walk you through as many of those as you want. All right, here we go. Solve for x. So in this case here, we're going to solve for x. So there's 2 ways you can do this. I prefer to do it one way, and you can do it the other way. I'm going to do it the way most of you prefer doing it. Most of you are weird and prefer doing it like this, where you distribute it into 2. And that makes more work, but I'm going to do it your way. 2x minus 16 is equal to 8. It works both ways, okay? 2x minus 16 is equal to 8. So that's my first step, distributing. And now I want to isolate the variable term. In other words, I want to deal with the constant that's keeping me from having this variable term all by itself. So I'm going to add 16 because that's the opposite of subtraction. I'm going to add 16 to both sides. And these cancel out. Now I get 2x is equal to 16 plus 8, which is 24. Well, now I have 2 multiplied times x, but I want to get x alone, so I have to deal with this 2 that's being multiplied times it. So I'm going to do the opposite, the inverse operation of 2, multiplying times 2, which is dividing by 2. When I do that, I get x equals 12. Bada bing, bada boom. All right, so now what you have on your paper, you have x equals 12 here. So just one more time, you should have the first, last, the period, the teacher's name, and you should have I can do this under that. You should have math rules in the center. You should have a fox in the bottom left. In the upper left-hand corner, I want you to draw Mr. Sims. How would you draw Mr. Sims? Try your best. All right, I'm interested to see what those look like. Okay, moving on. Here you go. All right, so number 5. So which radical expression is equivalent to 5 square roots of 3? So this one, oh, I like this one. This is a fun problem, right? So this one you're going backwards, which is super fun. So what you've been doing, right? Let's say you had the square root of 8 before, right? What we taught you to do is make your perfect squares list, right? We taught you make your perfect squares list and figure out which one goes into it. In this case, it'd be like square root of 4 times the square root of 2, right? 4 would have been the one on the list where you have 2 squared, right? So the square root of 4 ends up being 2. So I would have ended up with 2 square roots of 2. Well, this example shows you how you go this way. But this example, what they want you to do is they give you this, they give you the end, and they want you to go the other way, which is super fun. So let's think about it this way. If I got 5 by taking the square root of something. So if I want to figure out what I took the square root of, I have to think, well, what is 5 squared? 5 squared, Alexa, stop the timer. So 5 squared would be 25, right? Because if I took the square root of 25, wouldn't that give me the 5? Yeah. Then I'm also going to take, and I'm just going to bring my square root of 3 up. See, what I just did was I went backwards. I recreated this step here. How cool is that? That's fun. All right, now I have one more step to do. Remember, we have 8 became 4 and 2. But remember, 2 times 4 equals 8. In other words, we got this 2 by taking 8 divided by 4 to get 2, right? So if I multiply these two, I should get this. So if I multiply these two, I should get a number up here in my radical that this is all equivalent to. So 3 times 25 is 75. And that's my answer, which is right here. Ding, ding, ding. Winner, winner, chicken dinner. All right. Hey, well, it's been a pleasure doing this with you. Let me see how many problems we got through. We got through 9. Let me see if there's one that I just want to make sure we definitely hit before we go. All right. One last one. I want to make sure we hit this one because this one tricks so many students. All right. So just bear with me literally one more minute. Here we go. So, or 2 more minutes. So solve this inequality for y. So if you have this one here, you're solving it for y, and then it says which of the following values of y lies in the solution set of the inequality. So first step is to solve this for y. In other words, get y alone. So I'm just going to do that right here. 30 is greater than 4y plus 2, right? So my first step, I'm going to subtract 2 from both sides. And I get 28 is greater than 4y. Then what I'm going to do, I'm going to divide by 4 on both sides, right? And I get y over here, and I get 7 over here. All right. Now, oh man, they made it way too easy for you. Let's say D was not all of the above. Let's say D was 7. Haha, because this is where it gets tricky, and lots of kids mess this up. So in this case here, what you notice is it says that 7 has to be greater than y. What it means is this. It means whatever I put in here has to make this true. So 7 has to be greater than it, right? So a lot of kids will see this problem and they choose 7 because, hey, they solved it and they solved the 7, right? But that's not right at all. No, no, no. You don't want to do that, because here's what happens. They want to know which of the following values lies in the solution set. So they're saying, hey, which one makes this actually true? Like, which value can I actually put in for y and it will work? So let's try these out. If I put in 1 here, 7 is greater than 1. Does that work? Yes, that 100% works, right? If I had 7 is greater than 6, actually, that works too. Yeah. So actually, I got rid of the answer that was right. My bad. So 7 is greater than -2 is also right. So I'm sorry, I got rid of the all of the above. In this case, you need the all of the above. So the answer is all of the above because all of them work, okay? But just watch out for that tricky Mickey. What they tend to do a lot of times is give you the actual number that you search for as one of the answer choices, and so many students will choose that. But the answer in this case was the one that makes it work. In this case, all 3 of them made it work, right? Since all 3 of them are less than 7, or 7 is greater than all 3 of them, then the answer is all of the above. That was a little anticlimactic. Anyway, I wish you the very best of luck. Thank you for studying with Mr. Sims. I'm going to get off now so that you can get on to actually doing the rest of the study sheet. Hey, remember, this is just like the tip of the iceberg. You should be doing the whole study sheet. This is just to get you primed and in that mode where you're like, I can do this, right? As you wrote on the top of your paper there. So once again, on the top of your paper, I can do this. Math rules in the middle. It should have a fox on the bottom left. And then take your best shot at drawing Mr. Sims in the upper left-hand corner. I won't be offended. Oh, maybe I will be just a little bit, but not too much. All right. I wish you guys the very best. You're amazing. Have a wonderful, wonderful night and a wonderful testing experience. I wish you the very best. Good luck.